Hello everyone, I am Shubham Tanore from third year IT department from GS Raisoni College. So we have a project here for a classification. So we have a data set for in which we have to apply different classification algorithms. We have this data set of SUVs. We have a data set for people with their age, salary, and how likely they will purchase a car if they have purchased a car, and we're gonna predict how likely with a person with some salary with some age can have a car. So we will use its classification algorithm for it. So what is classification algorithm? As we know, it is a supervised machine learning algorithm. So basically in supervised machine learning algorithm can be classified into regression and classification algorithm. In regression algorithm, we can predict the output for a continuous values, but to predict the categorical values, we need classification algorithm. So as we knew that we are going to use a classification algorithm, and we also got to know about why we are using classification algorithm just to predict the categorical values. So basically, what is classification algorithm? Classification algorithm is a supervised learning technique that is used to identify the category of new observations on the basis of training data. In the classification, a program learns from the given data set or observations and then classifies a new observation into a number of classes or groups, such as yes or no, 0 or 1, spam or not spam, cat or dog. Classes can be called as targets slash labels or categories. Unlike regression, the output variable of classification is a category, not a value, such as green or blue, fruit or animal, etc. Since classification algorithm is a supervised learning technique, hence it takes a label input data, which means it contains an input with a corresponding output. So we are going to use four classification algorithm, which of one of which is logistic regression, another is KNN algorithm, third one is support vector machine algorithm, and fourth is naive Bayes classifier. So we are going to start with now logistic regression. So what is logistic regression in machine learning? Logistic regression is one of the most popular machine learning algorithm which comes under the supervised learning technique. It is used for predicting categorical dependent variable using a given set of independent variables. So in logistic regression, predicts the output of categorical dependent variable. Therefore, the outcome must be categorical or discrete value. It can be either yes or no, 0 or 1, true or false. But instead of giving the exact value 0 or 1, it gives the probabilistic value which lies between 0 and 1, as you can see. So logistic regression is much more similar to linear regression, except that how they are used. Linear regression is used for solving regression problems, whereas logistic regression is used for solving the classification problems. In logistic regression, instead of fitting regression line, we fit S-shaped logistic function which predicts the maximum and minimum values 0 or 1. The curves from the logistic function indicates the likelihood of something such as whether the cells are cancerous or not, a mouse is obese or not, based on its weight, etc. So logistic regression is a significant machine learning algorithm because it has the ability to provide probabilities and classify new data using continuous and discrete data set. So logistic regression can be used to classify the observation using different types of data and can easily determine the most effective variable used for the classification. Below image is showing the logistic function. So you can see this is a curve, S curve, which is that minimum value and maximum value. So these are the values between 0 to 1. Mm, One thing to note is that logistic regression uses the concept of predictive model it as a regression. Therefore, it is called logistic regression. But it uses to classify samples. Therefore, it falls under classification algorithm. Why it comes under classification algorithm? Just because logistic regression is a concept of predictive modeling as a regression. Now we are going to apply the logistic regression using Python. To implement the regression using Python, we'll use the same step as we have done for previous regression topics, such that first we will use doing data pre-processing step, then putting logistic regression to the training set, predicting the test result, test accuracy of the result, visualizing the test set result. So we'll get back to the code. So first we will write the data pre-processing step. That is, we will import all the libraries. So for import, I have imported NumPy, Matplotlib, Pandas, and now we are going to import the data set. So this is the command to import a data set. So I have a CSV file. So I will tell you first how to get this file. I will provide the link in description for this data set. First upload your data set to the drive. Then you have this folder icon here. Just click on here, mount drive. When you click on mount drive, will connect to Google Drive. For connecting to Google Drive, you have to run this cell. I have done it. You do it. Then you will get here. So mount the drive. After mounting, just here you will receive an option of my drive. And further, you just select your file and just click on copy path. You will get it. This is about it taking a while. Basically, I have told you I have connected it priorly. It is now giving some kind of error, so we will talk about it later. So just copy the path and just paste it here. I have a separate video for this. I will provide the link in description for that too. How to upload the dataset and just use it. So after importing the dataset, we'll extract the independent and dependent variable. So basically, I have written this command because I just want the second and third row for here for predicting fourth value. So using this second and third, we are going to predict the value for fourth row. So this is was indexing 0, 1, 2, 3, and for fourth is purchase, and this is age and salary. So now we will split the data set into training and test set. So using sklearn model, we'll import the trend test and split. After that, splitting the data set into training and test, we will do feature scaling. Feature scaling in logistic regression, we do feature scaling because we want accurate result of predictions. Here we only scale the independent variable because dependent variable have only 0 and 1 value. So below is the code for it. So this is the code for that. After that, we have after feature scaling, we will fit the regression model, fitting logistic regression to the training set. So we have well prepared our data set, and now we will train the data set using the training set. For providing training or fitting the model to the training set, we will import the logistic regression class of sklearn library. For importing the class, we will create a classifier object. We will create a classifier object and use it to fit the model to logistic regression. So this is the code for that. After that, we're gonna predict the test set result. So after our model is well trained on the training set, so we will now predict the result using the test set data. So this is the code for that, for predicting the data set. Now we will create a confusion matrix. So for why do we need confusion matrix? To test the accuracy of result. We will create a confusion matrix here to check the accuracy of the classification. To create it, we will need to import the confusion matrix function of sklearn library. After importing the function, we will call it using new variable cm. The function takes two parameters, mainly y true, the actual value, and the y print, the targeted value, written by the classifier. So this is the code. We'll include by a scalar confusion matrix. Now we're gonna visualize the training set result. Finally, we will visualize the training set result. To visualize the result, we will use a listed color map class of matplotlib library. So this is the code for that. In the above code, we have imported the listed color map class of matplotlib library to create the color map for visualizing the result. We have created two new variable, that is xset and yset, to replace xtrain and ytrain. After that, we have used nm mesh grid command to create a rectangular grid. So nm mesh grid command to create a rectangular grid which has a range of -1 minimum to 1 maximum. The pixel points we have taken are of 0.01 resolution. To create field counter, we have used mtf counter f command. It will create regions of provided colors purple and green in this function. In this function, we have passed the classifier predict. We have passed the classifier predict to show that the predicted data points predicted by the classifier. So this is the output. This is what we have done. We are visualizing the training set using listed color map. After that, we're gonna visualize the test set result. First, we have visualizes the training set result. Now we're gonna visualize the test set result. So for test set result, our model is well trained using training dataset. Now we will visualize the result for new observation, that is, as I said, test set, and the code for the test set will remain same as above, except that here we will use X test and Y test instead of X train and Y train. So here below is this, it is the code for that, as you can see. So here instead of using, here we will use as X set and Y test, as you can see here, X test and Y test. So this graph shows the result. As we can see, the graph is divided into two regions, that is purple and green. And green observation are in the green region, purple observation are in the purple region. So we can say that it is a good prediction model. Some of the green and purple data points are in different region, which can be ignored, as we have already calculated this error using confusion matrix, that is 11 incorrect output. Hence our model is pretty good and ready to make new prediction for the classification problem. So this was logistic regression. We have done that. So after that, we are going to learn about KNN algorithm. What is KNN? So KNN is a K nearest neighbor algorithm for machine learning. K nearest neighbor is one of the simplest machine learning algorithm based on supervised learning technique. KNN algorithm assumes the similarity between new case data and available cases, and put new cases into the category that is most similar to available categories. KNN algorithm stores all the available data and classifies the new data point based on the similarity. This means that when a new data appears, then it can easily classify it into well-suited category by using KNN algorithm. So KNN algorithm can be used for regression as well as classification, but mostly it is used for the classification problems. KNN is a non-parametric algorithm, which means it does not make any assumptions on underlying data. It is also called as lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the dataset at the time of classification, and then it performs an action on the dataset. So KNN algorithm at the training phase just stores the dataset, and when it gets a new data, then it classifies the data into category that is much simpler to new data. So one of the examples, suppose we have an image of creature that looks similar to a cat and dog, but we want to know either it is cat or dog. So for this identification, we can use KNN algorithm, as it works on similarity basis measures. So our KNN model will find the similar feature of new data set to the cats and dogs images, and based on the most similar feature it will put in either cat or dog category. So now we will apply a KNN algorithm. So before that we apply, so we'll know how does KNN work. So KNN working can be explained on the basis of below algorithm. So select the number of k of the neighbors, calculate the Euclidean distance of k number of neighbors, and take k nearest neighbors as per the calculated Euclidean distance. Among these k neighbors, count the number of data points in each category, assign the new data point. So assign a new data points to that category for which the number of neighbor is maximum or model is ready. So basically this is the algorithm for KNN. First we select the number of k neighbors, then we calculate the Euclidean. First we will choose the number of neighbors, so we will choose k is equal to 5. Next we will calculate Euclidean distance between 2 points. So you can see we will calculate the Euclidean distance between 2 points. This Euclidean distance between 2 points, which I've already studied in geometry, it can be calculated as, so Euclidean distance from A1 to B2 is like x2 minus x1 square plus y2 minus y1 square under root. By calculating Euclidean distance, we got the nearest neighbor as 3 nearest neighbors in category A, 2 nearest neighbor in category B. Consider the image below. So as we can see, 3 nearest neighbor are from category N. The new data point must belong to category A. So basically, we will implement the Python implementation. So what are the steps for KNN? So as we know, data pre-processing step, then fitting KNN algorithm, then predicting the test result, then test accuracy of the result, then visualizing the test set result. So for data pre-processing, we are going to do the same step, like I will show you in the code. So this is what, oh, sorry, I went to the different data. So pre-processing step is all about creating a data set, just importing libraries, then importing the data set. After that, extracting independent variables and splitting data set into training and testing. Then that is feature scaling. Now after feature scaling, we're gonna fit this model. So that is for KNN. We will fit this model in KNN classifier to import a training set. As we know that the pre-processing step for each classification algorithm is same. Take this into mind that pre-processing steps are same for where you're going to use same data, same SUV data for this. So for KNN algorithm, we're gonna first fit the model, the training set. We have written the code below to fit the model of a training set. So we can see that now we will fit the KNN classifier to the training data. To do this, we will import the K neighbors classifier class of scalar neighbors library. After importing that, we will create a classifier object of a class. The parameter of the class will be n neighbors, n underscore neighbors. That is define the required neighbors of the algorithm. Usually it takes 5. So metric is equal to mean cross CP. This is the default parameter. It decides the distance between the point. P is equal to 2 is equivalent standard Euclidean metric, and then we will fit the classifier to the training data. After that, we will by predict the test result. To predict the test result, we will create a ypred vector as we did it in logistic regression. Below is the code for it. This is the code for it. After that, we'll create a confusion matrix to test the accuracy of the model. So for testing accuracy, as we say, we know that we need to import confusion matrix from a scalar matrix, and after that we have to pass two parameters, that is y test and y prediction. So after that we will visualize the training set result. For training set result, according as we did it before. So you can see that you know that why we have, as I have explained before only, why we have imported this listed color map, then we have set values to extend and iterate. After that, we have use mesh grid. So all that I have explained. So as you can see, this graph is a little bit different from the graph that of logistic regression. So as we can see, this graph is showing the red points and the green points. The green points, this graph is showing red points and green points. The green points are for purchase, that is 1, and red points are for not purchase, that is 0 variable. The graph is shown an irregular boundary instead of showing a straight line or any curve because it is KNN algorithm, that is finding nearest neighbor. The graph has classified the users the correct categories, as most of the users who didn't buy the SUV are in the red region and the users who have bought the SUVs are in the green region. So this graph is showing a good result, but still there are some green points in the red region and red points in the green region. But this is no big issue, as by doing this model is prevented from overfitting issues. Hence our model is well trained. So after that we will visualize the test set result. First we have visualized the training set result. Now we will visualize the test set result. In test set result graph, we can see that the above we can see that this graph is the output of test data, and as we can see in the graph, the predicted output is well good, as most of the red points are in red region and most of the green points are in green region. However, there are few green points in the red region and few red points in green region. So these are incorrect observation that we have observed in confusion matrix. That is where it is the output. So now after that we will move on to vector. We're going to move on to the next classification algorithm, that is support vector machine algorithm. So what is support vector machine? Support vector machine algorithms, SVM, is one of the most popular survived learning algorithms which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of SVM algorithm is to create the best line or decision boundary that can segregate an n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. The best decision boundary is called hyperlane. So SVM chooses the extreme points vectors that help in creating hyperplane. So these extreme cases are called as support vectors. Hence, algorithm is termed as support vector machine. Consider the below diagram in which these are the two different categories that are classified using decision boundary or a hyperplane. As you can see, they have classified into two parts. So between this line is maximum margin. This is positive hyperplane. This is negative hyperplane, and this is maximum margin hyperplane, and these two are support vectors, this green point and this blue point. So basically we will understand with an example. Suppose SVM can be understood with this example that we have using KNN classifier. Suppose we see a strange cat that also has some features of dog. So if you want a model that can accurately identify whether it is cat or dog, so such a model can be created by using SVM algorithm. We will first train our model with lots of images of cats and dogs so that it can learn about different features of cats and dogs, and then we test it with its strange creature. So as support vector creates a decision boundary between these two data and the choose extreme cases support vectors. It will see the extreme cases of cat and dog on the basis of support vector. It will classify it as a cat as considered in the below diagram. So after that we will now, as you come to know that, so giving the maximum feeding of data, and after that creating a one boundary line between both the disks so that where it gets clear that this is cat and that is dog. So you basically got a basic understanding of what actually this SVM is. So basically, how does SVM work? So how is application is in Python? So we'll get back to that. So basically, Python implementation of a support vector machine. So first is a data pre-processing step. So we'll get back to our Colab. So this is a we are fitting the SVM classifier. The training set for this we will import the SVC, that is support vector classifier, from sklearn SVM. Library. Then we have a classifier, that is, we have a classifier. So basically, as we can see this, first we are going to fit this into, so we'll fit this, training set will be fitted into Svm classifier. And to create a Svm classifier, so to create a Svm classifier, we will import svc class from scale and Svm library. In, we can see that we have used a kernel is equal to linear, that is kernel is equal to linear, as here we are creating a SVM for linear separable data. However, we can change it to non-linear data, and then we fitted the classifier to the training data set, that is X train and Y train. After that, we're going to trace the test result by using the swipe rate. Swipe rate is equal to classifier dot predict X test. So after getting y-pred vector, we can compare the result of y-pred and y-test to check the difference between actual value and predicted value. So for that, we use a confusion matrix to check the accuracy. So now we will see that the performance of SVM classifier. Now we can see that the performance of SVM classifier, that how many incorrect predictions are there as compared to the logistic regression classifier. To create a confusion matrix, we need to import confusion matrix function from a scalar library, as I've told you before. We're gonna perform it. So as you can see that by using this, we're gonna get a confusion matrix. Now we'll visualize the training set result. That is, first we'll visualize the training set result. So for that, we will use the same code, same everything, same code. Now just you can see that there, this is what we got. As we can see, there are very less points. As we can see that above appear, so our output is appearing similar to logistic regression output. In the output, we got a straight line or a hyperplane because we have used a linear kernel in the classifier. We have also discussed about that for this 2D space of hyperplane in SVM is a straight line. Now we're gonna visualize the test set result. As you can see the above output image. So as you can see this output image, the SVM classifier has divided the users into two regions. So users who purchase the SU are in red region, and the users with the red scattered points. And users who did not purchase SU are in green region with the green scattered points. And the hyperplane has divided the two classes into purchased and non-purchased variable. So as you can see, this is we have done the prediction using so we have done the prediction using SVM, that is support vector machine. And now this is one more classification algorithm, that is nav-based classifier. So what is nav-based classifier algorithm? So nav is a algorithm is a supervised learning algorithm which is based on the Bayes theorem and used for solving classification problems. It is mainly used in text classification that includes a high-dimensional training dataset. So nav-based classifier is one of the simple and most effective classification algorithm which helps in building the fast machine learning models that can make quick predictions. It is probabilistic classifier, which means it predicts on the basis of probability of an object. So some popular example of NAM is spam filter, sentimental analysis, and classifying articles. So why it is called NAV based? NAV is it is called NAV because it assumes the occurrence of a certain feature is independent of the occurrence of other features, such as if the fruit is identified on the basis of color, shape, and taste, then the red spherical and the sweet fruit is recognized as an apple. Hence, each feature individually contributes to identity that is an apple without depending upon each other. So, Bayes, it is called as Bayes because it depends upon a principle of Bayes theorem. So what is Bayes theorem? It is also known as Bayes rules or Bayes law, which is used to determine the probability of hypothesis where prior knowledge it depends upon conditional probability. The formula for Bayes theorem is given as the probability of A is to be, that is probability of B upon A into P of probability of A upon probability of A, where P A to B is a posterior probability of hypothesis as A or observed on event B, and probability of B to A is likelihood probability of evidence that given the probability of hypothesis true, and probability is a prior probability, that is probability of hypothesis before observing the evidence. So PB is a marginal probability. So how does it work? What does so basically there are three types of naive Bayes model. One is Gaussian, multinomial, and Bernoulli. So we're gonna see is Python implementation of naive Bayes algorithm. So basically we are gonna use the same data set, that is of SUV. So what steps to implement is, first we'll do data pre-processing, then we're gonna fit nav based to training set, then predict the test result, then test accuracy of the result, and visualize the test set result. So for as we know, data pre-processing step is the same. So we are going direct with the fitting nav based to the training. So as we have now seen KNN, now fitting the nav base to a training set. So what basically we do, so after pre-processing, now we will fit the nav-based model to the training set. So below, this is the code for it. In the above code, we have used Gaussian NB classifier to fit the training data set. We can also use other classifier as per our requirement. So now we will predict the test set result as we do it. Then after that, we're gonna find the confusion matrix, that is predict the test, that is test the accuracy of this. So after testing the accuracy, we're gonna visualize the training set result. So next we will visualize the training set result using nav based classifier. So for that, this is the code. We're gonna use listed color map. As you can see, this graph is little bit different from the graph that we saw before. So even though we can see that nav based classifier has segregated. So you can see that nav based classifier has segregated the data points with the fine boundary. It's a Gaussian curve, as we have using Gaussian NB classifier in our code. So you can see we have used a Gaussian classifier, so that we have got a curve and it has been separated purchase and not purchase values. So as you can see, this was above we saw our training set result. So let's check the test set result graph. So the test set result graph, you can see that the output is final output for the test set data. As we can see that the classifier has created a Gaussian curve to divide the purchase and not purchase variables. So there are some wrong predictions which we have calculated in confusion matrix. So but still it is a pretty good classifier. So you can see that we have implemented a data set. So we have found that predicted that whether a person with some age and salary can buy has a car or not. So for that we have using four algorithms. One is logistic regression, another is KNN algorithm, third one is support vector machine learning algorithm, and fourth is nav based classifier. So we have applied all four classification algorithms. So here we have finished with our project. Thank you.